Well, the general trend of this channel has been away from mathematics and more towards philosophy. In fact, I have a whole host of calculus, algebra, some geometry, and maybe some trig videos that are just there. If you're a teacher, just take it, it's yours. The number theory videos, all kinds of interesting stuff. And I'm moving more towards the direction of philosophy, but I do want to revisit the original purpose of this channel, and that would be the Continuum Hypothesis, which is in a sense is both math and philosophy. In fact, somebody who's a regular subscriber said, well, you do need to continue making some math videos for me to have something to criticize, ha ha ha, and sure enough, I will. And I think that this probably will get criticism from that same said source. We're going to discuss Cantor dust, and we're going to discuss a very controversial belief that I've held that, again, this is the bridge between mathematics and philosophy. So it's a controversial belief, and that is the idea that 0 times cardinalities above all if not would be undefined. And I have never proven that, and I don't believe that I can. What I've stated is that I believe that it is consistent with known mathematics that one could postulate that, but that not necessarily that it is true. And I want to focus in, never mind the broad, if you want to know the broader argument of that, you got to go back to see my Continuum Hypothesis videos, and you're welcome to look at those. I've been trying to move away from that, but it was the original purpose of this channel, and before I do any kind of, I'm not going to completely break with math, so, all right. Cantor dust. What is Cantor dust? Well, we take a line segment, cut a third in the middle out of the line segment. We have, 1/3, and then the first third, and then the third third, and then we take each of them, cut the middle third out of that. Keep cutting the middle third until you get closer and closer to having an infinite number of points. In particular, you will have an uncountably infinite number of points, right? You will have 1 over 2 to, well, each, let's say you have 2 to the 0, 2 to the 1. These aren't points, these are line segments, but you're getting closer and closer to points. So you have 2 to the 0, 2 to the 1, 2 to the second power, or 4, 2 to the third power, 8. As you go all the way down, you'll have 2 to the all if not power, which would be the cardinality of the reals, okay, and that would be uncountable, an uncountable number of points. So you can think of having between 0 and 1, you would have something that would correspond in countability to every single number between 0 and 1, which would be uncountable. But notice what you have here. You also have, and I got this off Wikipedia, guys, so, really this would continue down to where you would have an infinite number of dots. You would also have something that would converge, that the measure, backtracking here, the measure of this we'll call 1, the measure of this we'll call 2/3, the measure of this we'll call, I guess it'd be 4/9, and you know the drill, it's going to get closer and closer to being 0. So you have an interesting ambiguity. You have something that an infinite number of points, the measure of which would be 0. And yet it's the same countability as the number of points between 0 and 1. So that same number of points either has a measure of 0, or would, if you were to scoop them all up, would combine into something infinitesimal, or if you put them together, would combine, it would combine into an infinitesimal, that's true, but that same number of points would define the line segment, the initial line segment that you had to begin with. And so there's an ambiguity with that. You do not have that ambiguity with all if not number of points. All if not number of points would correspond to the rationals between 0 and 1, and that would just, that would not define a line segment. You would not have simply the rationals. You would have uncountably more irrationals comprising that number line segment between 0 and 1 than you would have rationals. Okay, I think you understand what I'm trying to say here. If you had the rational numbers on a number line and you had that level of infinity, that would even an infinite number of those, all the rational numbers together would not define that line segment between 0 and 1. However, the reals, it's more ambiguous, because in one context, Yeah, and let's say this is between 0 and 1. You would have that level of infinity defining the reals, defining every single point between 0 and 1. But from another standpoint, you would not have it define the line segment. So does that affirm the idea that 0 times higher cardinalities above all if not is ambiguous and undefined? I mean, I'm not saying that it does, but I'm just saying it does raise an interesting question, because on the one hand you have that level of infinity. Well, you have an infinite number of infinitesimal points, each point the measure of which would be infinitesimal, and you have the level of infinity corresponding to the reals. It either defines something finite or it defines something that could correspond to 0 depending on how you arrive at it. So I'm going to throw that in as grist for the mill. It might be throwing gasoline on the flames. I don't know, but I hope you've enjoyed this video. Thank you.